Hello 108 students, Mr. McHugh here with you to get jump started on section 3.3. We're going to work with more with linear equations. This is going to be a big section for chapter 3, so let's go ahead and get started with something I've been trying to set you up here to be familiar with, and a formula that you're going to use a lot in this chapter, and that is the slope intercept form. Okay, so that's what objective 1 is going to be here. Good news, we've talked about this. What's interesting is, for years when I learned algebra, I've had teachers after teacher tell you y equals mx plus b. Y and the x are your variables. That's the ordered pair, x comma y. For every ordered pair you put in, you get the slope as m, and the y-intercept is b. And you work with it, and it's true. There's nobody's lying to you or anything. But what I found out was interesting. I never had anybody show me why is it y equals mx plus b. How can you go from ax plus by equals c, and we solve for y. I've done this with you already, and it all works out. And so I want to take a moment here to do an informal proof, and here's what's going on. I just want to add a little bit here to you. I want to extend out the x-axis just a tad. Notice I suppose you just drew a general line, okay? And when you drew it, when it crosses the x-intercept, you decided to label it with a variable because you don't know where it's at. It's any line, not a specific one. And we're going to use little a comma 0. Why 0? Because on the y-axis it's not going anywhere. Notice here on the y-intercept it crosses the y-axis at the y-intercept, and we use 0 comma b. I think mathematicians picked the b because they started off with a for it to cross the x-axis, so they used b to represent where it crosses the y-axis. Okay, so there's the y-intercept, there's the x-intercept, and here's a general line. And then what's interesting is somebody chose, and they said, what happens if we pick a general point on the line, x comma y, general? It could be anywhere. I could put it here, I could put it there, put it anywhere on this line. It goes on forever and ever with the arrows. And what if I figured out the slope between a general point and the y-intercept? And somebody said, well, okay, let's take a look at this. What would the slope be? Slope is what? Rise over run given two ordered pairs, a general x comma y and a specific ordered pair, which is the y-intercept 0 comma b. What would be the change in y? And so they wrote 0 comma b, x comma y, and in this case I subtracted going up. So they said y minus b, and then the change in the x, the horizontal, would be x minus 0. Okay, so they did that, and they signed that the m variable, and they said, okay, what can I do with this? Can I simplify a little bit? And of course, x minus 0 is x, and I left y minus b alone, equals m. And then somebody said, can we work with this? Can we kind of massage this a little bit? And any variable can be divided by 1 and still be equal, like an improper fraction. And then somebody had an interesting point that since you've got a ratio set equal to another ratio, you are allowed to use cross multiply. M times x has to equal the multiplying the other diagonal. This is what cross multiply is. And so they took 1, that's a positive 1, times y minus b. Okay, they did that, and they said, what would I have to do to isolate the y? That's the key to this step here. And all of a sudden, okay, 1 times y minus b doesn't change anything. So what can I do to isolate the y? They added b to both sides of the equation, and lo and behold, they had mx plus b, which are all different terms, equals y. And voila, the golden form is created. Y equals mx plus b. All I did was I swapped the left hand and right hand side. And thus m was the slope by definition, b was the y-intercept by definition. So now you've got the slope-intercept form. Okay, so with that little intro, I know it took a couple minutes there, but it's worthy to know where it came from. You're going to remember y equals mx plus b, the golden form. We're going to use it a lot. How can we use this? Example number 1 says if you were given a slope, -4/5, which is equal to m, and you're given the y-intercept as the ordered pair 0 comma -2, could you write the equation of a line? Remember, when that y-intercept the b value is right there at the y coordinate. And so I summarized them here. And all you need is the slope and a y-intercept, and you could use y equals mx plus b, substitute in -2 for the y-intercept, substitute -4/5 in for the m, the slope, the coefficient in front of the x term, and you're done. There's no more work to do. Y equals -4/5 x minus 2. Okay, you've done that. I love those problems. I love to see where the students understand the simplicity of y equals mx plus b, what it means. Given a slope, given a y-intercept, you go back and forth from linear equations to graphing. Okay, now if I wanted to graph this, did I graph this one? No. If I wanted to graph this real quick, can we just kind of give a rough go here? Here's -2 on the y-axis. Here's the x-axis. Now we need to go down 1, 2, 3, 4. 1, 2, 3, 4. And we need to go over 5. 1, 2, 3, 4, 5. So down 4 over 5 would be about right here. Try this on your own notes there to see if you can come up with that. And so this line right here is the equation y equals -4/5 x minus 2. They are equivalent. You could go back and forth between the two of them. Okay, let's take a look here. Let's look at objective number 2. They want us to, given the slope and the y-intercept, graph the line. Now I kind of talked about that real quick up here, but let's do it again. Okay, now, here's a challenge. Well, not yet. Excuse me, I take it back. Y equals 3x minus 6. Is that written in the golden form of the slope-intercept? Yes, it is. Y equals mx plus b. It's an exact matching, so you know the slope of this line is 3, the y-intercept is -6. You write that information. Notice what I did with the slope. 3 is also equivalent to 3 over 1. You need to have that improper fraction so you could do rise over run. Okay, so how do you plot this line? Find your anchor point, plot the y, think of this as the anchor, and you're going to find on the y-axis, where are you at -6, I apologize, -6, you're down here, and now you're going to execute and count the slope out. Slope is up 3 over plus 1, up 3 over 1, rise over run, 1, 2, 3 over 1, put you up here, 1, 2, 3 over 1, 1, 2, 3 over 1. Okay, could we do a negative slope? Let's practice that. Start back at the anchor point, aka the y-intercept. A positive 3 over 1 can be written as -3 over -1. So go down 3, 1, 2, 3, go back 1. And there you go. You're right on the line. Okay, folks, we've done it. Page 1 done. We've got lots to do in this section, so I'll see you for page 2. Okay, bye-bye.